For furthermore work in 11.1, we're going to look at cylindrical surfaces. We're starting to look at shapes that are in 3 dimensions. Any graph that we have in 2 space, or x comma y, our coordinate system, we can graph it in 3 space. These generally create something called a cylindrical surface, although most don't look cylindrical. The first couple will do are cylindrical though. If I look at x squared plus y squared equals 4, it's a circle of radius 2. Notice that there is no z listed though. So if I bring z into it by shifting to 3 dimensions, z is any value, which means we don't just have the circle in the xy plane where z equals 0 here. We can have a circle up above, circle down below. And generally what this does is it's creating a tube or cylinder. And one way of showing it is show the edges that go down. This is hard to draw by hand. Notice it's a little bit sloppy. If I want to show a line in the front, I would do this, show points that I'm connecting on the side of the circles close to us. And then I can do a dashed line for points on the back side of this tube. But this kind of shows there's a tube. Obviously, the more vertical lines you have, the harder it is to see. The circle shows that it's a circular shape, not like a square thing, a box going up and down. But that's one way of showing it. And that was when we had x squared plus y squared equals 4. Notice we had to take our graph and rotate it flatward. So the circle is coming out of the page as best as we can draw in 3 dimensions. If I've got y squared plus z squared equals 9, well, rather the 2-dimensional version doesn't have an x-axis. I could put y on top and z on the right, but since we do y on the right and z on top for a 3-dimensional space, I left it the same. Now, when we translate it to 3 dimensions, we have a circle of radius 3, but x does not have any restrictions. So x is any value here, which means I've got another circle down here. And I've got another circle back here. And you don't have to do, I could have just done 2 circles and shown it. But I'm trying to show how you go in and out of the page. Notice this doesn't look anywhere near as good as, say, a 3D rendered graphic from the computer. But if our x-axis is the center, it's like this is like a giant drum. This would be the center of the drum. It keeps going on infinitely. And I didn't do extra lines to show out of the paper and into the paper. I think you kind of gets the picture that way without doing all that. Again, a 2-dimensional or 3-dimensional drawing on 3D paper is a little hard to see. It's a little hard to draw, so you're gonna have to use your imagination for some of it. If we take a look at some more graphs, let's look at z equals y squared minus 1. Again, I did y along the right and z upwards. Think of it more like how if this was x and this was y, this would look like y equals x squared minus 1, which we're going to do in a second. But here I'm doing z and y. So this is a parabola. We all know the equation for parabola. It's parabola down 1. So I've done that over here. And if I want to extend this, let's see, I'll come down here. I'll go down 1, right 1, up 1, right 2, then up 4, I'll go right there and right there. And I'll draw a parabola like that. And maybe in this circumstance, I won't show a third one. Maybe just doing 2 is enough. But I do have some dots that I made for each of them. So maybe I'll connect them. So we've got effectively a piece of paper curved like this. We've got a half pipe. If we look at the same where we're doing y equals x squared minus 1 like we've got here, well, xy plane is now x is towards us, y is rightward. We still have that parabola, but the parabola is going like this. But now our z has no restrictions. So z is any value. Which means I can come up and do another parabola-like shape. And we do some connecting of the dots. And I might show the back. And then make a hard point on the graph to show that those are on that line. Which unfortunately just so happened to coincide with the x-axis, which I should have chosen a different point. Then I could choose another line. I've got a dot here. Let's make the equivalent up here and down here, and connected those as well. I try to make the vertical lines where we're showing the three-dimensional aspect of it lighter. It's a little hard to do with these big chunky pins that I'm using to add clarity on the screen. But I think in future videos, I won't need to use these because I've rotated the camera and regular text looks just fine. Ta-da. That should be readable on a computer. And that's it for this video.